In this video, we're going to be looking at taking the factoring by grouping pattern and solving technique and extending it into higher powers. So kind of incorporating a lot more factoring techniques inside of a problem that already requires factoring by grouping. So we see this problem on the screen and we know it's going to be a factor by grouping problem because there are 4 terms. So something else that we might want to look at is that we have a degree 6, right? We have a 6th degree polynomial, which means that we have 6 answers to find. So let's get started. Right, so factoring by grouping, the first thing I'm going to do, cut my equation in half and take out a GCF. So 16 and 64 are both divisible by 8. Actually, they're both divisible by 16. And then they both have at least 4 x's, so I'm going to take out 16x to the 4th. And that's going to leave me with x squared plus 4. And then I'm going to take out my GCF in the second half. So negative 9x squared and negative 36, both divisible by negative 9. And that's going to leave me with x squared plus 4. Perfect, that matches the first group. Right, so I'm going to take my common group and factor it to the front, and then take my leftover GCFs and put them in my second group. So then I need to set both of them equal to 0 and go ahead and solve. Okay, so over here on the left in my green equation, x squared plus 4 equals 0. I'm going to subtract 4. So then I get x squared equals negative 4. To get rid of my square root power, I'm going to take this, to get rid of my square power, I'm going to take the square root of both sides, which is going to give me a plus or minus on my answer. Right, and then I know that the square root of a negative is just I, and the square root of 4 is 2, so I'm going to get plus or minus 2i. So there's 2 of my 6 answers down. So now let's go over and focus on the blue equation, 16x to the 4th minus 9 equals 0. So we have an x to the 4th power here. So this is, if I look at this, 16 and 9 are both perfect squares. So this is actually a difference of perfect squares problem. So the first thing I'm going to do is rewrite them. So it's something squared minus something squared. So 16x to the 4th, if I want to square something to get that back, right? 4 squared is 16, and x squared would give me x to the 4th, right? Multiply those exponents together. And then 9's pretty easy, right? 3 squared is equal to 9. So then applying my factoring pattern for difference of squares, I just take those 2 terms, put them into both, and then do opposite signs in the middle. So now I have 2 more equations to solve, right? So I'm going to solve 4x squared plus 3 equals 0. And I'm a big fan of color coding, so I'm just going to change this color to purple. So that way it definitely stands out from the other one. So I'll solve the blue one first, right? So subtract 3, 4x squared equals negative 3. I'm going to divide by 4. I'm not going to write that out. And then I'm going to take the square root of both sides to get rid of my square power, which is going to give me a plus or minus on my answer. So I'm going to get x equals, so I have a negative 3 in the top, so I know I'm going to get an I, right? So that takes care of the negative. And then in the numerator, I can't take the square root of 3, so that's just the square root of 3. And then the square root of 4 is just 2. So that's answers 3 and 4, right, because of the plus or minus. So then to solve my purple equation, add 3, right? So it's going to be essentially the same thing, except we're not going to have that negative on the 3. Take the square root, which is going to give me a plus or minus on my answer. Right, I can't take the square root of 3, so that stays square root of 3. Square root of 4 is 2. And there are answers 5 and 6 for our problem.